Okay, so we acknowledge we are hosting the lands in Mississauga of Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize an enduring presence of all First Nations, Métis, and Inuit people. So today is day 11. Time is just going. It is what it is. I'm giving out the test today for Unit 4. Okay. It's unfortunate, but it's just how it is. Time is just flying. So the test is coming out today, and you still have to do these things today. So the test is due tomorrow, but we'll see. But it is due tomorrow, but we'll see. There is a quiz for the stuff that you're learning today. Here is a quiz that's a formative quiz. It doesn't count for marks, but you can, do it to kind of help you to understand. So we're looking at periodic behavior, periodic functions, transformations, stretch compression, that kind of stuff, and then graphing and applications. Maybe not so much applications, but so we're gonna go into. I haven't put the test in, so the test I'll put it in after our Zoom session. Okay. And because of time, I may cut the Zoom session short because I know some people may have stuff to do afterwards, so I can't go all the way till 10:30. We'll mess up some people, so I'll stop at 10. So it'll be a shorter Zoom session, but at least you guys we'll have the work to get work for you guys to get done. Today's the 15th. So the 15th, that means we're going to behavior. And when we look up behavior, this is what we're looking at. And there is a worksheet for that. And then we're going to look at graphing. Okay. That's what looking at there. And then, well, there's a video for graphing. And then here is the lesson. And here is the worksheet. And then here is transformations, similar to what we've seen before with exponential and with quadratic and just with regular functions. And then here's application. And here is, so, there's a lot of things here and I get it. It's a lot. So maybe you just want to, test through it. Like, don't spend forever for these worksheets because they don't count for marks, right? So like it says there, it doesn't count for marks. So don't take forever. Just maybe look at it, do some questions, check your understanding, and then move on. Okay. I think we're going to start at, today is the 15th, so we can start here. So let's go through this, and then I think this is a video. We can go through the video together. So let's see if I can go through this lesson, and then we'll go to the video for the graphing. Okay, so this is the very beginning that we should know. You guys should know the very basics for periodic behavior. Okay, so a periodic function, that's what we're looking at right now, is basically a function that has a pattern of the y values that repeat. Okay, so when we say y values, let me start writing on the screen so you guys can understand. Can I write? Yes. So here is my x and y. If something repeats, right? It's repeating. So from here to here, it repeated, and from here to here, it repeated, and then so on. So there's a pattern where it goes like this on the y, and it goes like this on the Y, and it's going along the X. So it repeats, right? So anytime you have one cycle, that means you have one pattern. So from here to here was one cycle, okay? And if I go again, that's another cycle. A period is the horizontal length of one cycle. So how long it took to get from here to here, that is the period, right? How long it took for, how much time it took to complete one cycle. And then amplitude is the distance between the max and min. So the distance between the maximum values. So my amplitude would be from here to here. Okay. And then from here to here. It's my amplitude. Okay. So that's just the basics. So now let's get into more stuff down here. Okay, so here we go. We're looking at an example. So let's see what it says. Is how to find the period of a function. Choose a convenient x-coordinate to start and then move to the right and estimate the x-coordinate to where the next cycle begins. Find the difference of these x-coordinates to calculate the period. So if we're looking at this one here, it starts, let's say we pick this point and we look at the pattern. Oh, it looks like it's going to repeat here. So the period is the length of the cycle. So it looks like the cycle went from, it was -6. So the period is, it went from -6 to here. So the period is 0 minus -6. So the period is 6. Okay. So now you look at this question here. It doesn't look like there's anything repeating. So therefore there's no pattern here. So this is not a periodic function because there's no pattern. It's just random. Here it's a periodic function because the cycle repeats. Here it's not. Yes, it's going up and down, but there's no repeating. Okay. So now amplitude, it says here, how to find amplitude. Amplitude is the half difference between the max and min. So it's in between. So you can see here, if I look at this, here's my max, here's my min, and then somewhere in between is the midpoint. So from there to there, okay, would be like the mid, but it's going down to negative, and then over here would be again the midline, and then here's the max. So the midline, so basically the period is the halfway distance. Okay, so to calculate that, shows you right there. Amplitude is the maximum of the y minus the minimum of the y divided by 2. So here maximum was 3 minus the minimum was -1. So 3 minus -1, that's how you get the amplitude. Okay. So now we're gonna go on to the next one. Okay, this one here, we can calculate amplitude. We can also calculate period. Okay, because we know that now. So you can see the period is the length of the cycle. So it starts here, and then we go to here, and it looks like it repeats again here. So the cycle goes from here to here. Let me use my mouse. Goes from here to here. Okay, that's the cycle. So that means the period, how long it took, it went from -7 to -1. So the period is basically the difference between. I go from -1 to -7. My period is 6 units. And then my amplitude is the midpoint, the halfway point between the max and min. Okay, so my max is 3, my min is -2. So 3 minus -2 Divide that by 2 gives you 2.5. Okay, 2.5. Okay, is my amplitude. Okay, then we go down to the next part. So for the following function, determine. So now you want to determine. So this is the function, right? This is the graph. This is the function. And it's now the question is, it's asking you the question, okay? What is f of 2? And what is f of 3? Okay. So that means we're saying, what is x? What is the function when x is 2? And then when the function, what is the function when x is 3? So when x is 2, my function, which is my y value, remember this is going to be the y value. Okay, what is my y value? So at f of 2, my y value is 1, right? And then when x is 3, my y value now is -1. Okay, so that's what we're looking. That's what we're saying here. Okay, and then over here, when x is with this one here, x is 5. That means f of x or f of 5. What is that? Looks like it is 0. Okay, that's what we're looking at there. And then we'll scroll down and see the examples. Right, so here you go, f of 2, like I just said, f of 2, where x is 2, y is 1. And we just showed you up there, y is 1. When f is 5, when x is 5, so f of 5, that means x is 5, y is 0. Okay, and so on. So we do the same thing for each of these. Okay, so that's how you get that. So now determine the 4 values of x so that f of 2 equals to 2. So that's what, so basically we're saying here, our y equals to 2, what is x? If our y equals to 2, what is x? Okay, and it's saying here get 4 values. So when y is 2, let's go over here, y is 2. That means our x is 0. Our x is also 6. If I go this way, our x is -6. Okay, so it's giving you a couple here. Where are we? We're here. So that means our x is, so that f of 2, okay, so our x, yeah, so that's what I was saying. So for the y equal to 2, our x is 6, that's what we said. And then our x could be, so x could be 6. And then it's not showing you this way, it should show you this way. Our x could be 0. I think I said that. There you go. F is 0. X is, y is 0. Y could be 2 or y could be 6. My bad. I'm saying the wrong thing. When x is 0, y is 2. When x is 6, y is 2. When x is 12, y is 2. Okay. And then it's only going in the positive direction, but it didn't actually go this way. So it's actually just going this way. So 0, 6, and if I can keep doing the pattern, right? I can do the pattern, say 12, and I can do the pattern again and say 18. Okay, so every time I count 6 on the Y or on the X, I'm going to get 2 for the Y. If I count 6 on the X, I want to get 2 on the Y, right? But also you can go in this way too. Okay, so that's that example. So here is like a problem question. A cutting machine chops a plastic into appropriate lengths. The following graph shows the motion of the cutting blade on the machine. So here's the cutting blade on the machine and it's cutting plastic. So you can see here is the max height of the blade. It's at 0.5. And then when it comes down, and goes back up. So the time it goes down to go back up, that's going to be the cycle. Or not even, it's not even, you just go there just yet. The max height is 0.5 and the minimum height is 0, okay? So now we're looking at, it's gonna cut, so this piece of plastic is moving on a conveyor, right? So as it moves, the blade comes down to cut it at a certain length. So basically that's a periodic cycle, but it's gonna come down every certain amount of time in order to get that length. So it comes down at 3.5, okay? And then the period where it comes down again is going to be 7.5, right? Or we could look at it from in another way. It's up at 4, and then it goes along, comes back down, and then it's up again at 8. So the period is 4 seconds. Either way you look at it, when it comes down here, 3.5, and then when it comes down here, 7.5. The difference is 4 seconds. Over here, it's back up at 4 seconds, and it's going to go back up at 8 seconds. So the period is 4 seconds. My max and min, which is going to be my amplitude, help me determine my amplitude, is 0.5. Okay? So now when we look at it, here's our height, here's our max and min, here's our amplitude, and this is the period. We said it's 4 seconds. Okay? Now it's saying here, state the next 2 times the blade will strike the cutting surface. Okay, so we know it comes down and hits the surface at 7.5. It started at 3.5. So at 3.5 it hit the surface. And at 4 seconds, 7.5. At another 4 seconds, it would be 11.5. At another 4 seconds, it would be 15.5. Okay, so every 4 seconds it's hitting the surface. You can see there 11.5, 15.5, right? And we're saying 0, that means the height is 0, right? So when our x is 11.5, our height is 0. When our x is 7.5, our height is 0. When our x is at the very beginning, we said 3.5, our height is 0. Okay, so this is what we do here. And that is it for this one. So let me go on to the next one. So now let's look at, so there's questions on that. You guys can do it on your own. Now let's go into graphing. Looks like there's a video for that. So let's click on the video. Taking a while to load up.
Back to school outfits are tricky. Saving on plans? Easy. Pair 5G mobile and Ignite internet plans, each from $55.
Let's look at how we can relate the primary trig ratio, sine, cosine, tan, to the unit circle. Remember, a unit circle is a circle centered at the origin with the radius of 1. How we can rate the three primary trig ratios to this unit circle, and then use that relationship to help graph what sine theta and cos theta actually are going
Okay, so in this video, we're going through how we graph, okay, your sine, right? Because we're looking at sine theta and cos theta, right? When you're graphing it, okay? And when we're graphing it, right, our theta is our angle, right? But we can always go back to the unit circle to help you do that, right? And sine theta would be our parent graph, and then cosine theta would be our parent graph for cosine. And then later on, then we apply the transformations. Transformations will make the graph look skinnier, or move it up, move it down, stretch it, compress it, that kind of stuff, right? So we're just learning about the parent function, the parent graphing of these trig functions, okay? That's what we're doing right now.
to look like graphically. So we'll graph sine theta in yellow there. We'll graph cos theta in green down here. But first, let's remember the relationship between the primary trig ratios and the unit circle. So keep in mind, three primary trig ratios are sine, cos, and tan. And you know the word SOHCAHTOA tells you that sine of any angle is equal to its opposite side divided by the hypotenuse. Cosine is equal to a.
Okay, I'm gonna skip that. We guys all know that, so we're gonna go a little bit faster, right? We know about the SOHCAHTOA. Okay, so let's get into it.
Trig ratios. So first of all, remember that the initial arm always starts along the positive x-axis here, and then our terminal arm is going to rotate counterclockwise around. So we could draw our terminal arm is going to rotate some angle. We'll call that angle theta.
Okay, you guys know that from yesterday, right? So we're gonna fast forward a little bit, right? And we know where it hits the unit circle, right? That will be our x and y, and our x and y, basically our y is our opposites, our x is our adjacent, and then this distance here is our radius, which is the hypotenuse. So we learned that yesterday, right?
X-axis. In this right triangle, this side, well, let me just erase this here so you can better visualize this right triangle. This side has length x, right? Because to get to this point here, we would have had to travel x.
Okay, so we're gonna fast forward that because you guys learned that yesterday. Okay. Okay, so in the unit circle, so now we're doing the unit circle now, right? So back up, our radius in a unit circle is 1. So that's why we put 1 there, because our radius is 1 in a unit circle. It's 1 unit. So we call it radius of 1. So now when we are looking at our SOHCAHTOA, right? Y over 1. Okay, when we say y over 1, well, y over 1 is just going to be just y, right? We know that. And then our cos is going to be x over, or cos theta is going to be x over 1, right? Again, it's just in a unit circle, that means it's just going to be just x. And our tan, the last one's going to be our tan. Well, I guess we don't have to do that right now. I guess it's just going to just looking at sine and cosine. Okay, so that's what you get, right? So if we go back to here, right? So in a unit circle, our cos theta is just going to equal to x. Our sine theta is just going to equal to y. Okay, because it's x over 1, and anything over 1 is just, you don't show the 1 anymore. Okay, so we'll play it from here.
Cos theta equals x. So let's use that relationship to be able to actually figure out what the ratios are going to be at some key points as we rotate around this unit circle. So let me just get rid of all this. So we are going to start along the initial arm along the positive x-axis. So that is going to intersect the unit circle right here at the point 1, 0. And we're going to graph the ratio for sine as we rotate 360 degrees around this unit circle. So if we are going to find the ratio for sine theta, remember sine theta is always equal to y. So,
oops, let's go back. So sine theta is equal to y, right? So now if we're looking at this point here, and you see this is made up of x and y. So the sine theta, this angle is basically angle 0. So theta is angle 0. So if you know angle 0 is right here, therefore sine of angle 0 gives you 0, because you can see that because our x and y, or y is 0, okay? And our x is cos theta, and our x is actually 1. So cos theta, and he's explaining it. So let's just go. Let me just go a little bit. Let him explain it. But that's what we're doing here. See, he's going to make that of angle 0 because that's where we are. And then angle 0 is equal to sine of angle 0 is equal to 0, right? That's just how we look at that. And then we're going to look at some fast forwarding a little bit. Just going to write it down. There you go. Now we're going to look at the cos of angle 0. Cos of angle 0 should equal to 1 because based on this is their x coordinate, and cos theta equals to x. And that means if our angle is 0, that means our x is 1. That means cos of 0 equals to 1. And I was going to do it. Okay. So now what he's doing, he's just going to go doing all the sines first. So let me back up. Let me just follow him. He's going to do all the sines, the sine values, and then he's going to do all the cos values. So let's just do that.
Sine of 90 degrees. What if we rotate 90 degrees, and now it's going to intersect the unit circle right here at the point 0, 1. Well, the y coordinate of that point is 1, so sine of 90 is equal to 1. So when we've rotated 90 degrees, the sine ratio is now 1. And now that's the furthest we're ever going to get from the x-axis as we rotate around the unit circle. So the biggest the sine ratio is ever going to be is 1. So when we've rotated 90 degrees from the initial arm, the sine ratio is 1. What if we've rotated 180 degrees? We've rotated 180 degrees, it's now going to intersect.
Now you're going to see the pattern, right? So over here, this would be our x is -1, our y is 0, right? So therefore, sine of 180 equals to 0, right? And you can see the pattern, right? So now we go over to here, you're going to put a dot at 180. So graph is going like this, where my mouse is, you can see, it's going like that. And then you can see a pattern. Now let's look at when it gets to 270. I'm going to draw a line at 270. There you go. So 270, the coordinate of that is 0 for my x, and my y is -1. So that means sine of 270 should equal to 1. Or sorry, -1. Right? So there you go. You can see the pattern, -1. And then when you go to 360, right? So sine of 360 should be the same as sine of 0. So sine of 360 is equal to 0, right? So you can see it over here, that you can see what's going on over here, right? So the graph is going like this, right? So you can see how from here to here is one period, right? One period looks like it's 360, and our max and min is 1 and -1. So that means our amplitude is just 1, okay? So this is the parent function of sine equal to y is equal to sine theta. And I believe it's doing the same thing for cos, okay? So if you do the same thing for cos, let me fast forward the video. So he drew the line there, and it repeats. And it repeats the other way too. I'm not sure if this video will get into cos. Well, look at it is right now. You can see, right? Our cos, remember, is all the x values, right? So if you go around the circle, when our cos, this angle is 0. So when cos of 0 equals to 1, cos of 1 equals to 0. I'm saying it wrong. Cos of angle 0 equals to 1. Cos of angle 90 equals to 0. Cos of angle 180 equals to -1. Cos of angle 270 equals to 0. Cos of 360 equals to 1. So that's what he's going to be doing here. He's going to be plotting it on this graph for the cos numbers. So you can see. So that's how you get cos. Okay. So now these are all the parent functions, like I said. So when we are applying the transformation, this graph may shift up, may shift a little bit to the right, to the left. It also can shrink. The period can shrink, right? Or the amplitude can stretch up. Okay, so that's what we're doing when we're talking about transformations for these. Okay, I know it's 12, it's 11. Sorry, it's getting close to that time. So let's see, what else can I show you? Okay, here's the worksheet for that. Transformations. Let's go through transformations. I have to go through just a little bit of it. Hopefully, I can speed through this to get the gist of it. Okay, so the main thing when we're looking at the transformation, right? The same thing as before, our A, our K, our D, and C, okay? So this is really important to look at this table here because everything comes from here. Our A is our amplitude, okay? Our K helps us find out what is our period. So our period is equal to 360 divided by K. Okay, that gives you the period, right? So 360 divided by K gives you the period. And it's going to stretch and compress based on a factor 1 over K, right? So if K is 2, that means my factor is 1 over 2. That means if it's a 1 over 2, that means it's a fraction. So you're compressing it, okay? If K was 1 over 2, or if K was a half, then I plug in here 1 over a half. When you flip it around, that means it's 2. And if the value is 2, that means it's greater than 1. That means it's stretching it, okay? And here is our D, right? Which it shifts it to the left to the right, like we know that from before. And our C shifts it up and down, okay? And we're always going by our parent function. So this is our parent function, sine x, cos x, or cos theta, or sine theta. So this is our parent function, right? Here's a parent function. This was for cos, and this was for sine, and this was for cos, okay? So now here is, we look at a transformation. So here is a transformation right here. So y is equal to 2 sine x plus 1, okay? So if we're looking at it like that, we're gonna look at, well, A is our amplitude, right? We know that. And A will stretch it, will stretch in the y. So it's stretching by a factor of 2. So any y value here, I have to, for my parent function, I have to multiply by 2 to get over to here. And then also too, there's a vertical shift to +1. So I'm multiplying, my X is multiplying, my Y is multiplying by 2 plus is adding 1. So because it's going up. So on this side here, I have 2Y plus 1. So my X values stay the same. My Y values change by multiplying by 2 and adding 1. This is what it looks like now. Okay. And if you look at this graph, our C is the midpoint line. Our amplitude is 2 because we got that from here, 2. But also too, if you look at here, the amplitude is 2. So I go from 1 to 3, the amplitude is 2. If I go from -1 to 1, my amplitude is 2. Okay. And our period, that's what we have to calculate, is basically 1 over K. Our K value in this case is just 1 because there's no other number in front of the X, so it's just 1. So our period is going to be 360 divided by K, which is 1. So our period is just 360. Okay. The number of cycles between 0 and 360 is 1. Okay, now we're doing this particular transformation. This one looks a little bit complicated, right? So our A is -1.5. Okay. And this is, we're looking at the cosparent function, not the sine. This one was, we're looking at the sine. Now this one we're looking at the cos. Okay. Our K is 3. So therefore it's a factor of 1 over K. So that means 1 over 3. That means I'm compressing, but it's a fraction now, 1 over 3. So every X value, I'm going to divide by 3. Our phase is 30 degrees. So every X value, I'm going to add 30 degrees. And our Y shifts up. We're going to, for every Y value, we're going to add 0.5. Okay. And then, so our Y values are going to be multiplied when you look over here, are going to be multiplied by -1.5 because our A is 1.5. And we're going to add 0.5 to it. So that's what's going to be for our Y values. For our X values, we have K is equal to 3. So our factor is basically based off 1 over K. That means every X value we divide by 3, and then it's phasing, it's shifting on the X by 30 degrees onto the right. So we're going to add 30 degrees plus, we're going to do every X value divided by 3. And then you get a new graph. Looks like this. Okay. And so on. So this is sort of the same repeat. So I'm not going to repeat this. Sort of the same thing. Okay. So you see that. Here's our parent function. And then what's the transformation? Okay. So that looks like we're done with that example. And let's go back. And here is a worksheet. I'm not going to go through this. I think we can stop here. You guys can go through this on your own. I think that is going to be it. The time is short. I don't want to take too much time. I already started late. So I'm going to put the quizzes there. The worksheets are there. I'm going to post the test right after I'm done this Zoom. Again, it's due tomorrow at midnight. We'll see what happens. I may help you guys, but you got to really try to get that deadline. Okay. So that is it for unit 4. We're done unit 4, just like that. Then we go to our next unit. Our last unit is, we're going to start our last unit tomorrow, which is unit 5. Okay. So just like that. So I'm going to let you guys go. I'm going to post this recording, and hopefully you guys can get as much done today. Okay, guys, take care. Bye.